Hello friends and potential friends, Jack here from the Geeky Gardens. As you can see, I'm not in the garden today. Instead, I decided to dip into the geekier side of my life. Strictly speaking, what this video is about has nothing to do with gardening, though I can come up with a few situations where some of the technology might be useful in a garden or in a homesteading environment. But if you decide you're not interested in this sort of thing and you want to go look somewhere else, my feelings won't be greatly hurt. However, I do have a story to tell, and you might want to hear it. Besides which, if you hang around, you might even get some insights into how a geeky mind operates when it's dealing with technical challenges. You see, I have this friend I'll call Buddy. He started losing his sight a number of years ago. He had to stop driving about 10 years ago, so he started getting around town on his bicycle. Sometimes he'd ride 50 or 60 miles in a day. He's been run off the road a few times. He's run into a few things. He's had things run into him. He's been through numerous treatments and procedures and surgeries trying to save his sight, or at least slow down the loss, but ultimately he was declared legally blind. So he went out to the Blind Services Division, learned how to use a white cane properly. They taught him how to use a few apps and applications that are designed for assisting the blind, and he just wasn't satisfied with all of that. Besides which, he couldn't figure out a way to hook that white cane to the front of his bicycle to where it'd be any use to him. So he started doing research. He found a number of medical devices out there to assist the blind. Because they were medical devices, they usually were priced at hundreds, if not thousands of dollars, which of course he couldn't afford. So he kept looking for alternatives, and that's where I came into the story. The first device we found was the HC-SR04 sonar sensor. This device has got a range of about 4 meters, equivalent to about 10 to 12 feet. And it works by sending out a sound pulse and then detecting and calculating the time it takes for the pulse to return when it hits something. We decided to pair this with a vibrating motor similar to what you'll find in your smartphone if you take it apart. That'll let the user know what's going on. And we decided to base the system on an Arduino since it has more than enough power for what we need to do. And it's pretty inexpensive. So with that, a handful of resistors and transistors and diodes and capacitors, we were ready to start designing something. All I needed then was to figure out what we were going to design. So I started looking at the spec sheets, attending YouTube University, and surfing the web looking for circuit diagrams and program code that would help me build some sort of a device out of all these parts. This rather crude circuit diagram was what I used to build the first prototype. I did it on a regular perf board and using an Arduino Uno, just wired it all together. And that got me to the point where I could start doing some programming and some testing. Later I redrew the circuit, make it a little bit clearer, still hand drawn on paper, imagine that. Someone that's been playing with computers for 35 or more years turns to pencil and paper to do his diagram. But it worked. I designed this one so that it would fit onto a little generic circuit board that I happen to have in my toy chest, and it would allow me to mount all of the components on that same circuit board. Every time I made a change in the circuit based on my testing, I redrew the circuit diagram. That got old real fast. So I started looking for some software to use to do this for me. I settled on a product called Eagle PCB Designer, mainly because that seems to be the most popular software package amongst all the circuit geeks that I'm familiar with. It's got the ability to draw out the circuit. It can also generate Gerber files that we need when we want to get a PCB created. And it's got a nice board layout feature so that you can figure out exactly where to place all the components. I drew up the first diagram, and then we started trying to put things together and ran into that roadblock. Neither Buddy nor I is able anymore to solder in those tight spaces that we needed. So we enlisted Buddy's son, had him do the soldering, and we came up with the first mobile version of what was later to be known as the Blind Buddy. In fact, it was while I was getting up to speed with the Eagle software that I came up with the name of the Blind Buddy. I thought it was appropriate since Buddy was going blind, and this device was supposed to serve as his buddy to help him get around again. We put it together on that first circuit board we got made and got it working. Unfortunately, I don't have a picture of that first circuit board that we laid out. Actually, that might be fortunate because it was sloppy. I would not be proud of that at all. But it did work, and it got us going. And pretty soon I came up with a second prototype design. This one's a little bit clearer, and it clearly shows that the Blind Buddy is composed of three pretty simple circuits. At the top, you see the power circuit. It's got a socket where you can plug in the power source, and then a switch to turn it on and off, an LED to indicate whether it's on or off, and a resistor to make sure the LED doesn't blow up on you. The Blind Buddy can use pretty much any power source between 7 and 12 volt. In fact, that first prototype, you might have noticed, we hooked it up to a 9-volt battery, and it worked with that. We really were looking for something a little more long-lasting, but we'll get to that at some point. Right below the power circuit, you see a simple 4-pin socket. That's where the Sonar device would connect. And its circuit was just 4 traces that connected to the appropriate pins of the Arduino. And then below that is the motor circuit. Like I mentioned earlier, that's the most complicated part of this whole design. It uses a couple of resistors, a transistor, a capacitor, and a diode in order to operate that buzzer motor. Another nice thing about the Eagle software is that it's got the circuit board layout tools that let you determine exactly where the various components are going to be on the circuit board. Our main goal, 2 goals in fact. Number 1, to make the board as small as possible, because the smaller the board, the cheaper they are to manufacture. And the second was to reduce the number of traces that have to cross other traces, because every time one trace crosses another, you have to drill through the circuit board and run one of those traces on the bottom end of the board. We got it done, and then we went off to have more circuit boards created. So let's take a look at the Blind Buddy. This is the original prototype. It does not include the power circuit because it gets its power from my computer using the USB cable. As you can see right now, if you look at the top right or the top center, that little buzzer motor is vibrating almost constantly. That's because it's getting some reflections off the desktop into the sensor. If I hold the sensor flat, the motor stops. I'll just keep holding it flat to keep that noise stopped, and then I'm going to switch over to another scene here, and we'll take a look at the code we used to make the Blind Buddy work. If you're familiar with Arduino code, it's got basically 3 sections. At the top here, I've declared a few variables so that I can use names instead of numbers. Makes it a little bit easier if you need to move the pins around or something like that. I also have a calculation here for turning the distance into the time out and back. Arduino code always starts with a setup function. This is where you initialize your variables. Start off by turning the serial on, set the baud rate. Then we set the trigger pin to output. That's on pin 11. The echo pin is set to input, pin 8. And the motor pin is on pin 3. We set that to output. Basically, a signal goes out through the trigger pin, causes the sensor to send out its pulse. The return pulse, or the time, is returned on the echo pin, and then we turn the motor on and off as needed. The second or third main part of the Arduino code is a loop. Basically, this loop runs continuous as long as the device is powered up. So the first thing we do is determine the distance that was detected. I'll show you that function in a moment. Then we print out that distance to the serial monitor, add the mm for millimeters after it, and then we go down and determine what we want to do with that distance. If the distance is between 2,500 millimeters and 10,000 millimeters, roughly, I don't do math in public anymore, but I think that's somewhere in the neighborhood of 6 to 10 feet. It buzzes real slow because whatever was hit was quite a ways away. Otherwise, if the distance is between 1,000 millimeters and 2,500, it buzzes faster. Or if the distance is between 0 and 1,000 millimeters, it buzzes very fast because something's getting pretty close. And if it fails all three of those checks, it just doesn't buzz at all. We then delay for 100 milliseconds and then start the loop all over again. I mentioned I'd show you how we calculate the distance, or how we get the distance. That's in this function. First thing we do is turn off the trigger pin, just to make sure it's turned off. We wait 3 milliseconds or microseconds, and then we set the trigger pin to high, or turn it on. That's when the pulse gets sent out. We wait another 10 microseconds for the pulse to go out and back, and then we turn the trigger pin off again. We come down and we read the output of the echo pin, put it into a variable. We use that variable to calculate the time it took to go out. Notice we're dividing by 2, so we're only getting one direction for our time. Multiply the time by the speed of sound at sea level, and that gives us a distance in millimeters. So we return that. The don't buzz just writes out to the serial monitor, don't buzz, real imaginative. Buzz slow writes out buzz slow to the serial monitor, then turns the motor pin on, setting it to high. Delays for 400 milliseconds and turns the motor back off again. One long buzz. Buzz fast for intermediate distances, prints out something to the serial port or the serial monitor, turns the motor pin on, waits for 250 milliseconds, and then turns the motor back off again. And the third one, buzz very fast, again writes out to the serial monitor, turns the motor pin on, waits 100 milliseconds, and turns the motor pin back off again. And that's the whole code. It's as simple as that. And a lot of that, everything that's written to the serial monitor, doesn't really need to be there. That's just there for debugging purpose. So now let's see what we can do with it. I'm going to bring up the serial monitor here. And this is real time. And you may be, there it goes. Okay, moved it around a little bit. Right now it's looking at the desk. It's about 3 inches away. So it's buzzing real fast. You can see how the distance that it's calculating. As I move it around, now I'm looking at a monitor about a foot and a half away. Turn it a little bit more, and it's looking out into the room where it's not detecting much of anything. I'll see if I can get it to find something at an intermediate distance. A lot of things close. It's the hard part. There's a lot of stuff in here, and most of it is pretty close. But as you can see, as I move it around, it's finding things at various distances. Very fast, nothing at all. Oops, I'm too close to it too. Let's see how long my arm is. No, now it's getting my thumb. Basically there, we got it to buzz slow for a second. And now it's hitting something at the intermediate. And now it's not buzzing at all. But as you can see, it does function. And that's the Blind Buddy. So, what have we learned? Well, number one, we learned that it's possible. Number two, we've learned that because of the distance restrictions of the SR04, it's not real useful outside, though it does serve some pretty good use and purposes when you're inside, especially in an environment that you're not familiar with. We took the mobile prototype, and we attached it to the back of a glove that Buddy wears from time to time. And he uses it when he goes out to the store or various places like that. It keeps him from running into things. He still uses his cane. The blind Buddy does not replace the cane. But then, like he explained to me, one of the main purposes of the cane is to let people around you know that you're blind. Another use that he likes to use it for is to trip people that don't pay attention to that first use. I have seen him stick it between people's legs before. So, the second thing we learned is that we need something with a lot more distance. The SR04 is only good for about 10 feet. That's not going to do any good at all on a bicycle. By the time he detects something that's 10 feet out, he's going to hit it before he can do anything with it. So we did some more research. Now bear in mind that when we started this project, it was about 5 years ago. And the best thing on the market at that time was this Sonar sensor. Since then, they've come up with newer technology. We have recently acquired this guy. Officially, that's called a time of flight detector. And there's the business side of it. That's a LiDAR system, a LiDAR sensor. It uses light to determine the distance to objects. Very similar technology to what they're using in some of these automated cars so that they can detect various things. In fact, Buddy just told me yesterday that they're starting to find out that with some of these automated cars, bugs are getting stuck in the LiDAR systems and causing accidents. Not the kind of bugs I deal with in my programs, but the ones that are out flying around, the ones we deal with in our gardens. So the next generation, we're going to build one using that LiDAR chip. See if we can get that to work on his bicycle so we can get Buddy back on the road. And it's been a fun project. Got me back into programming a little bit when I was feeling kind of burned out. And it helps out my friend a little bit along the way too. So the moral of the whole story is if you're out on the town and you see an old geezer on a 10-speed bicycle wearing dark glasses, whether it's daylight or nighttime, coming at you, he's probably got a white cane folded up under his arm and a cheesy looking gardener's hat similar to the one I wear from time to time. Get out of his way because he can't see you. I hope you enjoyed this. I'll see you on the next one.